It's very easy to misconfigure access control lists. There's a lot of parts in an access control list, especially when we are dealing with extended access control lists. But what are some of the things we might mess up on? Well, we might mess up on the wildcard mask. Remember that the wildcard mask is a range operator. It allows us, when coupled with an address, for example, 10.1.1.0, to identify a range of addresses. So if you had 10.1.1.0 with a wildcard mask of 0000255, it's indicating that the ACL is going to apply, the entry is going to apply to traffic in that range from 10.1.1.0 through 10.1.1.255. If you had a wildcard mask instead of 0063, then your range is 10.1.1.0 through 10.1.1.63. So you're really defining a range of values with your wildcard masking. And if the wildcard mask is not correctly specified, then you'll be matching the wrong addresses. So the more complicated you make your wildcard masks, the more chance you will have of making an error. When we're dealing with extended access control lists, we can filter based on source and destination IP addresses, source and destination port numbers, protocols, and we have to make sure that we are identifying the right ports and the right protocols. Did we specify TCP correctly, or UDP correctly, or EIGRP correctly, or OSPF correctly, or BGP? You know, its port number. What is BGP using? Is it using BGP? No, it's not. It's using TCP port 179. It's those little things that you have to keep in mind while troubleshooting. Because if you apply an access control list on an interface and you accidentally block protocol 47, that's GRE. If you block TCP port 179, you're blocking BGP. If you block 88, that's EIGRP. 89, OSPF. You have to be very, very, very careful when you're creating your access control list and identifying the ports. Don't accidentally block traffic you intend to permit, or don't permit traffic that you're supposed to be blocking. Remember, ACLs are processed from top down. Top-down processing, immediate execution upon a match. And then if there is no match, out of all the entries in that ACL, everything else is denied, implicitly denied. Directionality is huge with access control lists. You can apply ACLs inbound or outbound to an interface. So I can create an ACL and apply it inbound on this interface, or outbound. Same thing here, same thing here. But here's what you have to realize. Directionality and what the ACL is designed to do go hand in hand. You can't create an ACL and just simply say, I'm going to apply it inbound on this interface. No, because the logic may no longer make sense. If you are trying to deny traffic from this PC from going here, and you create an ACL, then you better make sure that it's denying traffic sourced inbound on this interface, or sourced outbound on that interface. You see, the directionality is really, really important. Same thing with traffic from the internet. If you say, let's deny all traffic outbound because you're trying to prevent inbound connections from the internet, that's not going to work. You have to deny the traffic inbound on the interface if you want to deny incoming traffic from the internet. So you have to take the time to craft the ACL, figure out exactly what you intend to do with it, and apply it in the correct direction on the best interface. And typos and human error. We're human. We're going to make mistakes. But if we make mistakes, we have to be able to troubleshoot these mistakes. Do we know how to analyze where an ACL has been applied? So which interface in which direction? Do we understand the logic, the order of processing of an access control list, so we can understand how the way we've created our access control list will be processed by the device itself? We have to have a solid, in-depth understanding of ACLs in order to be able to troubleshoot them as well. But when it comes to troubleshooting ACLs, when in our troubleshooting process are we going to even consider ACL as an issue? Well, let's look at this flow chart. We have an issue and we start troubleshooting. Do we have end-to-end connectivity? Yes? Well, then there's no problem at all. But if we don't have end-to-end connectivity, do we have physical connectivity issues? That's layer one, isn't it? So is there a physical connectivity issue? Yes or no? Yes, fix it. No, move on. So we're just going to keep moving on through our troubleshooting flows, looking at different layers of the OSI model. But I'm a divide and conquer type of person, so I would have a tendency to ping first, because ping is going to eliminate a lot of the potential issues here. Depending on which IP address we ping, for example, if you ping the router that's going to get you on the internet and it fails, well, then let's back up from there. Can we ping our default gateway, as we see here? Can we? Yes, no? If we can't, let's fix that problem. Maybe we configured it incorrectly on the client. Maybe the IP address on the default gateway itself is incorrect. And we just keep moving on down the line from there, pinging to see where things fail. But let's say we find a particular area in the network, let's say between two different routers, R2 and R3. Well, why can't we ping beyond that? Why can't we access resources beyond R2 and R3? Is it possible that after we analyze EIGRP or OSPF neighborships, we analyze route filtering, we check routes out, and so on and so forth, that it is an access control list that's blocking the traffic? It's quite possible. So at that point in time, we are analyzing the ACL, but as we are troubleshooting, it's really not towards the end. We're going to troubleshoot a whole lot of other issues first before we even get to the ACL. And sometimes you may just feel like it is the ACL. So you want to start with that first? Go right ahead. That's if you know your network very, very well. But other than that, most of the time, if it is an ACL problem, it's going to be the last thing you check.